Have you ever tried to order a deuterated solvent or a labelled organic compound and realised the price varies massively depending on where you look? Or maybe you're working on OLED research and you've heard that deuterated materials can improve device lifetime, but you're not sure where to source them reliably. In today's presentation, we're going to break this down clearly. We'll explore where to buy deuterated compounds, how to compare suppliers, and how to avoid overspending. By the end, you'll know exactly where to look, what to evaluate, and how to make smart purchasing decisions. So let's start with the real question. Why do we care about deuterium at all? Deuterium is simply hydrogen with one extra neutron. But that tiny difference has huge effects. In NMR spectroscopy, deuterated solvents are essential because they eliminate proton background signals, giving cleaner, more interpretable spectra. Typical examples include D2O, CDCl₃, and DMF-D7. In OLED research, deuteration can actually slow down certain chemical degradation pathways, helping devices last longer. You'll often see deuterated carbazole derivatives used in TADF materials to improve efficiency and stability. So whether we're analysing molecules or building new display technologies, deuterium matters. Now, here's where things get tricky. Deuterated compounds aren't everyday chemicals. They require isotope-enriched precursors, specialised reaction conditions, and careful purification. This means pricing depends on the isotopic purity, usually between 95 and 99.8%. The chemical purity, especially important for spectroscopy. And the scale of production. Small scale means higher cost. Because of these factors, two suppliers can list the same compound at completely different prices, and that's normal. Understanding this prevents surprise and helps you budget strategically. If your primary need is NMR solvents or standard deuterated reagents, these are the most reliable global suppliers. Cambridge Isotope Laboratories, considered the gold standard for high-purity deuterated solvents. Merck/Sigma Aldrich, great catalogue coverage and usually easy to order through institutions. Thermo Fisher Scientific, ideal for bulk orders and academic lab procurement systems. TCI Chemicals, especially strong for organic deuterated building blocks. And here's an insider tip. If you're in academia, your institute may already have contract pricing with these suppliers. This alone can cut costs 10 to 60%. When we move from solvents into OLED research, the sourcing becomes more specialised. Companies like Lumtech offer custom isotopically labelled OLED materials. Oscilla is excellent for small research quantities with fast delivery. And Canto/TCI are good sources for deuterated aromatic precursors. Common OLED-related deuterated molecules include carbazole D8, used in host-guest systems, mCP-d and CBP-d for transport layers. For custom emitters, companies will often synthesize them on request. This is common in research and early device development. Sometimes, the exact compound you need just does not exist commercially. Maybe you need deuteration at a specific position, or a molecule that isn't commonly sold. In that case, custom synthesis is your path. Major providers include CIL for high-quality isotope labelling, Synquest Labs, known for fast turnaround, Deutero GmbH for complex labelling routes. You simply submit your structure, receive a quote and timeline, and once synthesized, the compound is delivered with verification data. It's expensive, but sometimes it's the only route. Before placing an order, here are the key evaluation factors. Isotopic purity. What percentage of hydrogen is replaced by deuterium? Chemical purity, especially critical for spectroscopy work. Documentation. Always ask for a certificate of analysis and preferably an NMR spectrum. Packaging. Poor sealing means moisture contamination. Lead time. Some compounds are ready to ship, others are made to order. And one red flag to always remember: never buy from suppliers who cannot provide documentation up front. If you want to stretch your research budget, here are some simple but highly effective strategies. Start with the smallest quantity. Test it and scale later. Ask your institution about vendor contracts, huge savings. Reuse NMR solvents when permitted. Drying and distillation can recover them efficiently. For OLED materials, consider in-house deuteration if the required labelling pattern is simple. And a surprising money saver: share bulk orders with colleagues working on similar materials. It works. Deuterated compounds are sensitive, especially to moisture. Store them in the dark, under nitrogen or argon, using septum caps to avoid exposure. For OLED emitters, glove box or vacuum-sealed storage is ideal. If there's one rule to remember, moisture is the enemy. Even slight contamination introduces unwanted proton signals. So to summarize, choose suppliers based on purity, documentation, and reliability. Optimize costs through smart purchasing and shared ordering. And protect your compounds through proper storage and handling. Thank you for going through this session. Keep experimenting, keep questioning, and keep creating new materials that push science forward.